Algebra 2, so 6.4, here in this section, we are talking about quadratic modeling problems that involve borders. So borders around pictures, things like that. So quadratic modeling involving borders. So in this case, what you'll need to do is read the problem and come up with the equation that models this particular scenario. And they're going to work, one of a couple of flavors. Either you know the size of a picture that you want to frame, or you know the total area that the frame and the picture take up on the wall, and you're trying to figure out basically the width of this border. Okay, so look, a 4 by 6 inch photograph is in a wooden frame of uniform width. The area of the frame's front face is 39 inches. How wide is the frame? So a common thing when you see a word problem, go to the question. The question says, how wide is the frame? That's what I need to know, and I don't know. So that's a good place to define my variable. So in all of these problems, you're going to have some variable. Let's just make it x. Let x be the width of the frame. Okay? So sorry about that. I highlighted the wrong thing there. Let x represent the width of the frame. So what do we know? What do we know about this photo? This photo is a 4 by 6 photo. That means that the area of this photo is 24 square inches. Okay. What is the area of the frame? They tell me that the area of the frame is 39 square inches. Okay. Now I know conceptually, just looking at this without doing any algebra, you know that the area of the photo plus the area of the frame, that has to equal the total area. So when I put this picture up on the wall, the area of the photo plus the area of the frame equals the total area that this takes up on my wall. So how do I figure out? So I know the area of the photo. What is the area of the photo? That is 24. The area of the frame. Well, I know the area of the frame is 39. What I don't know is the total area, because that depends on how wide the frame is. So go back to your variable here. Let x represent the width of the frame. That means that, let's look at what we know at this point. So I know that from here to here is 6 inches. And then I also know from here to here that it's 4 inches. Okay, so just to write it, I know that this is 6, this is 6, this is 4, and this is 4. Okay, now we're going to let x be the width of the frame. So what that means is, in every situation, x is going to be the length from there to there. And so this distance here is going to be x. The distance from here to here is going to be x. The distance from here to here is going to be x. So x is the width of that frame all the way around. Okay, so what I'm after then is I want to know what is the length of this side right here. Okay, how long is that side? Well, I know that there's 4 inches taking up by the picture. The top border represents x, and the bottom border represents x. So that is 4 plus 2x. So this side is 4 plus 2x. Look at this side up here. How long is that? Well, it's going to be 6. You've got the frame width of x and the frame width of x on either side. So this side is 6 plus 2x. So I know that the total frame and picture is going to be 6 plus 2x by 4 plus 2x. So if that's the dimension of that, then I know that area is going to be 6 plus 2x times 4 plus 2x. Now I'm into a quadratic model because this is now a quadratic equation. Okay, so 24 plus 39 is equal to 6 plus 2x times 4 plus 2x. This is the equation that needs to be solved, okay? So you've got a couple of choices here. To use our calculator, we want this to be equal to 0. Okay, so what I could do is I could say, well, this is 6 plus 2x times 4 plus 2x minus 24 minus 39 equals 0. Okay, so I've got it equal to 0. So on the test, you're going to be asked, what equation do you need to solve? You could stop right there. That is the equation that needs to be solved. Now, what I can do in my calculator, I could come in and say, okay, well, the way we do that in our calculator, menu, algebra, polynomials, complex roots of polynomials. So what do I have there? I've got 4 plus 2x times 6 plus 2x minus 24 minus 39. That is the equation that is already set equal to 0. So I just say comma x, solve that for x. And I see there's an error there. Sorry about that. I thought this calculator could do it, but it can't do the multiplication of these things together. So you're going to have to go ahead and multiply all this together. So let me back up. The teacher calculator will do this, but yours will not. So what I have to do here is I've got to expand this. So when I FOIL this, I get 24 plus 12x plus 8x plus 4x squared minus 24 minus 39 equals 0. Okay, now that equation I could put in the calculator just like that. Okay, so let's just go back and verify that I can do that. So if I go back to my calculator, so let's do that real quick. So I will do menu, algebra, complex roots. Okay, so what did I have there? In this case, I've got 24 plus 12x plus 8x. So 24 plus 12x plus 8x minus 4x squared, is that right? Plus 4x squared, minus 24 minus 39. So minus 24 minus 39, that has been set equal to 0. That's set equal to 0, so just say comma x, solve that for x. X is equal to negative 13 halves or 3 halves. Now remember, what was x? X was the what? The width of the frame. Okay, so if x is the width of the frame, it doesn't make sense for the width of the frame to be a negative number. So 3 halves is the width of the frame here. So I get that x equal 3 halves. Now the other thing you can do, you could work on this and simplify this. Less typing if you say, okay, well the 24 and the 24 cancel. This is 4x squared plus 20x minus 39 equals 0. So I can do a little bit of algebraic simplification and do this same problem over again. So I could say, well, menu, algebra, polynomial, complex roots, it is 4x squared and then plus 20x minus 39 comma x, and I get negative 13 halves, 3 halves. So either way, I come up with x equals 3 halves. So what was the question? The original question was, how wide is the frame? So we know that the frame is 3 halves inches wide, or 1.5 inches wide. Okay, so again, it looks a little complicated when you get the equation, but it all boils down to the area of the picture plus the area of the frame equals the total area in this particular problem. Let's look at another one. You are decorating your bedroom and you have this picture that says, I love algebra, if you remember your complex numbers. The poster is 11 by 14 and the frame has an area of 150 square inches. What is the width of the frame? So again, go to the question. What is the width of the frame? That's how I define my variable. let X equal the width of the frame. That means that this is X, this is X, this is X, and this is X. Okay, you know from looking at this picture that the area of your poster plus the area of your frame equals your total area. So what is the area of that poster? Well, that is an 11 by 14 poster. So 11 by 14 would be the size of the poster. So then when you multiply 11 by 14, you get 154. So I know that this is 154. That is the area of the poster. The area of the frame, they tell me that is 150. So the area of the poster plus the area of the frame is equal to the total area. So the total area. So what is this? If you look at the left side, this is X, and then this is 11, and this is X. So this whole side is 2X plus 11, or 11 plus 2X, doesn't matter. Look at the side down here, you've got X, 14, and X, so this is 2X plus 14. So I know that the area of the total environment is going to be, what, 2X plus 11 times 2X plus 14. That's the equation that needs to be solved, okay? In order to solve it, I want to set it equal to 0. So you're going to have 154 plus 150 is equal to 4x squared plus 8x plus 22x plus 154. Okay, I want to set this equal to 0 and then solve it. There's a simplification here that you've got 154 on both sides of this equation. So you're going to have 0 is equal to 4x squared plus 30x minus 150. So that's the equation that I need to solve. So I just go to my calculator and then menu, algebra, see polyroots. So 4x squared plus 30x minus 150 has been set equal to 0. So I just say comma x, solve that for x. That's when I realized I made a typo in my algebra here, so taking care of that. When I did this original foiling, you multiply the first two terms, you get 4x squared. You multiply the outside terms, 2 times 14, that's 28x. The inside terms, 22x, and then plus 154. So we know that the 154 canceled, okay? So in this case, you had the 150 over here. So 0 is equal to 4x squared plus, and if you look at this, that's going to be 50x minus 150. That is set equal to 0. So 4x squared plus 50x minus 150. So let me go back and just correct that typo here. So we get x is equal to negative 15 and 5 halves. Remember, x is the width of the frame, so it only makes sense for that to be 5 halves. So in this case, I get x equal 5 halves. So 2.5 inches is the width of this frame. Okay? So again, both of these problems work the same way. Be real careful with the algebra. Like you just saw me trip up and make a mistake. Be real careful and check that when you get to your calculator. So just go back and double check and make sure you've done everything correctly here. The outer dimensions of a picture frame are 20 by 12. The area of the picture that is exposed is 84 centimeters squared. What is the width of the frame? Now this is going to be more like a problem test. There is no diagram already drawn for you. It is your responsibility to do that. So let's take a look at this. The outer dimensions of a frame are 20 by 12. So that means that this side from here to here is 20, and this side from here to here is 12. Okay, so those are the outer dimensions. Okay, the area of the picture that is exposed is 84 centimeters. So I've got a picture, and I know that this is 84 centimeters squared. What is the width of the frame? Well, let's let x equal the width of the frame. So that means that you have a distance of x, that buffer, all the way around this picture. Okay? Now, what do I know in this particular problem? Okay? Before we did the problem where we knew the area of the photo, but we didn't know the area of the outside photo plus the frame. Now it's different. I know the total area of the frame, but I don't know the actual dimensions of the inside picture. Okay, so I got to figure out what does that mean here. So what would the dimensions of this picture be? Okay, so if you think about it, what is the distance from here to here? The whole distance is 20. Okay, how could I backtrack and find out what the length of the side of the picture is? Okay, so if you look at it, on this side you've got x, and then you have a picture. Okay, so what I see here is that this side right here of this picture is going to have to be 20 minus 2x. That's how long that side has to be. And then if you look at this side of the picture that you see from here to here, that side of the picture has to be 12 minus 2x. Okay, because everything is in relationship to the width of the frame. Okay, so in this case, if we look at it, what I see here is 20 minus 2x times 12 minus 2x. That is the area of what? That is the area of the photograph. Okay, do you know anything about the area of the photograph? Do you know what it is? Well, you know that that has to equal, in this case, 84. Okay, so that is the equation that I need to solve. So if I do the multiplication here, 12 times 20, so that's going to be what? 240. And then if I look at the outside, it's going to be minus 40x minus 24x plus 4x squared equals 84. So now what I see is 4x squared minus 64x plus 240 minus 84 equals 0. Okay, I could put it in the calculator just like this. Okay, or you could come over here and say, what is 240 minus 84? And you get 156. So that's going to be 4x squared minus 64x plus 156 equals 0. So I'll go to the calculator in order to solve this. So menu, algebra, C poly roots. So I've got what? 4x squared minus 64x plus 156. The key to C poly roots, you have already set it equal to 0. And so you just say solve this for x, and you get 3 and 13. Okay, we're going to have to look at this. So I get x equal 3 and x equal 13. Okay, so let's think about it. I got to look and see which of those numbers do they both make sense. The outside dimensions of the frame are what? 20 by 12. Okay, so think about it. What if I had x equal 13? Okay, so we know that this photo is 20 minus 2x by 12 minus 2x. Okay, if x is equal to 13, that means this photo is 20 minus 26 by 12 minus 26. So this photo is a negative 6 by negative 14 photo. Okay, that doesn't make sense. The dimensions of the photo can't be negative 6 by negative 14. So this doesn't make sense. The only thing is x equal 3, so this is a 3-inch frame. So that border has to be 3 inches. Okay, so again, each of these problems you've got to really key in on, what do I know? Do I know the dimensions of the inside photograph or poster or whatever it is? Then I'm going to build a quadratic equation that has plus 2x in it. If I know the dimensions of the total outside area that takes up on my wall, then I'm going to have something that's like a minus 2x, because I'm going to have to subtract to use the variable to get the dimensions of that inside photo.